And the last thing we're going to do in this Polar Coordinate Extra Credit project is to just explore some fun curves. So the first family is the rose curves, and they're going to be in the form of a cosine n theta or a sine n theta. So for example, r equals 3 cosine 4 theta. I'm just going to put it in the calculator, and you can use Desmos for this. So r equals 3 cosine 4 theta graph. And they end up being really fun graphs. I'm going to make my window X-min. I'm going to do -5 to 5 so you can see it a little clearer. And this should really be a fun part of the project. Okay, they end up being these nice little flowery type curves. And instead of 3 cosine 4 theta, what if I said r equals 2 cosine 3 theta? And you'll start to see some trends go on. So this has 8 petals. And if you look, this petal goes out to a distance of 3, right? So my first one had 8 petals, went out to a distance of 3. And if I do r equals 2 cosine 3 theta, you get a very different curve. The petals go out a distance of 2, and there's only 3 of them. So you can learn a little bit about these numbers by exploring this project. So those are rose curves, and you can use sine or cosine. So you put any number in for a and n, and you'll get some curves. This is all in section 6.5, so you might want to just look over section 6.5 before you try doing these. Okay, the next family of curves is limacon curves, and in this case you have an a and a b, and it's always just a 1 theta. So let's do r equals, let's say, 3 plus 2 cosine theta. So y equals 3 plus 2 cosine theta, and we're going to graph. And you get this fun looking shape, if you can see that. And if I did 3 minus 2 cosine theta, I would get something different. So I'm just going to change that to a minus. And if I did something like, let's do the smaller number in front, so let's call this a 1 minus 3 sine theta. And you're going to see that it flips vertically this time, but so r equals 1 minus 3 sine theta. So these shouldn't be too hard to do. You're going to make some of these and then cut them into a Google Doc. And you get this funny looking, for this one here, you get one that looks like this. And it has this little piece in it. You might want to do this in Desmos. It looks, they look better in Desmos. Okay, so those are the limacon curves. And then if we go down to these lemniscate curves, see how it's r squared equals? So when you put in your calculator, you're going to have to put in r equals the square root of a sine 2 theta. So if we go y equals the square root of 2 sine 2 theta, and this is always a 2 for these, for the lemniscate curves. And then we have to close our square root sign, and let's see what we get. Okay, and there's your lemniscate curve for that one. It looks like this. So they sort of look like figure eights. So for this part of the curve, for the project, you'll be just exploring what these different numbers, the a's and the b's and the n's, do for these families of curves, and you'll make a Google Doc. All you basically do is copying the graphs into the Google Doc that I prepared. Okay, good luck with the project.